right? So what do you mean by a hash function? So a hash function is used in hashing, is also called as a hashing algorithm. So it uses a hash key to locate a data record, right? So generally a hash key is a string of characters which is transformed to shorter length hash address by a hashing algorithm, right? So in the previous case, mod 10 was a hash function. So given some input, you are going to apply the mod 10 function to generate the address for the student ID, the bucket address for the student ID. We call it as hash function, right? So generally a hash function, it is used to locate a data record. It's a string of characters which is transformed onto shorter length hash address by hashing algorithm, right? So a hashing function can vary from a simplest mathematical function to any complex function. So we use a hash function so that it could easily and quickly generate results, right? Right. So for example, in hash function you have a division method, right? So a hash function which uses division method is represented by h of k equal to k mod m, right? So where k denotes the hash key and m is chosen to be a prime number, so which is greater than the total number of keys, right? So you can have different hash functions. You can have a hash function h of k is equal to k mod m, or h of k is equal to k mod of m plus 1, right? So whenever you are using the formula k mod m, it indicates the resultant of the remainder when k is divided by m. So the first formula, the range of hash addresses from 0 to m minus 1, whereas the second formula, the range of hash addresses from 1 to m, right? So when you are going to use h of k is equal to k mod m, the range of hash address is going to be 0 to m minus 1, whereas once you are going to use the second formula, the range of hash address is going to be 1 to m. The second formula is h of k is equal to mod of k mod m plus 1. See, let us see some examples and then I will come back to theory. So for example, consider a class with 68 students, similar to your class, with each student given a unique 4-digit number, right? So for example, you have 68 students in the class, and each and every student is given a unique ID, like Aadhaar ID or a roll number, like namely like 1024, 2448, 3466, or some unique student numbers, right? So here student numbers denote the hash key k, and we choose m. So m is going to be some value which is a prime number, and it should be greater than the total number of keys preferably, right? So here m is going to be total number of keys is going, total number of students is going to be 68. We are going to have m to be a prime number which is 71, which is greater than the total number of keys, right? So using this formula, h of k is equal to k mod m. So 1024 mod m is going to be 30. Similarly, h of 2448 is equal to 2448 mod 71. It's going to be 34. And finally, h of 3466 is going to be 3466 mod 71, which is going to be 58. So 30, 34, and 58 are the hash address of the students associated with the student number 1024, 2448, and 3466, right? Similarly, if I am going to use the second formula, h of k is equal to k mod m plus 1, the value of the hash address results in 31, 35, and 59 respectively, right? Right. So this is how we use a hash function, right? So hash function in division method, it uses a simple division. H of k is equal to k mod m, or h of k is equal to k mod m plus 1, where k is going to be the key, hash key, and m is going to be a prime number which is going to be the greater than the total number of keys. And whenever you are going to use h of k is equal to k mod m, the first formula, it results in the hash address ranges from 0 to m minus 1, Whereas the second formula, it results in the hash address ranging from 1 to m, right? We'll see some more examples for hashing and maybe come back, right? So this is given in your textbook. So for example, you have the same instructor table, right? So here the hash index is generated by based on search key on ID of an instructor file. So the hash function is going to be right. So it's going to be ID mod 8, right? 13, 20, 13, 20, 26, 32, right? So the hash function in the figure computes the sum of the digits of the ID mod 8. So for example, a person, instructor with the ID 76766. So what is going to be the sum of the digits in the ID? It's going to be 13, 20, 26, 32. 32 mod 8 is going to be 0, right? So the first record is stored in the bucket 0. So what about the second ID? The second ID, the sum of the ID is going to be 1, 2, 3. So 3 mod 8 is going to be 3, right? So we are going to store the second record in the bucket 3, right? So what about the third record? Aravind, you are following the class, right? Aravind, Kiran Reddy, Kiran, Kiran, Dominic.
Yes, sir.
Dominic, you are able to follow this class, right?
Yes, sir. The third bucket, you take the sum of the digits. It'll become
Right.
3 mod 8.
So what is the sum of digits in the third record? 4, 4, 4, 5, 5, 6, 5. So the sum of digits mod 8. So what is going to be the sum of digits? It's going to be
4, 5, 5, 6, 8 will be 10, 14, 19.
25 mod 8, right?
Yeah, 25 mod 8. Yeah,
So
so
25
that will
mod 8
be
will be stored in bucket 1,
bucket 1.
because 25 mod 8 you get 1. So you are going to store it in the bucket 1, right? So whenever there's whenever more than one whenever you are going to apply this hash function, sum of digits in the instructor ID mod 8, so sometimes a collision occurs. So what do you mean by collision? So for example, 4, 5, 5, 6, 5 also it refers to the bucket 1. Similarly, what about the instructor ID 76543? So again, it's going to be 13, 18, 22, 25. 25 mod 8 is going to be again 1, right? So when more than one record, it refers to the same bucket, we say that collision occurs, and we'll be using this bucket chaining, where we'll be adding records into the bucket and we'll represent this information in this format. So it means that in the bucket 1 there are 2 records, 4, 5, 4, 5, 5, 6, 5, as well as 7, 6, 5, 4, 3, right? Similarly, if you look into bucket 5, so you have more than 4 records in the bucket 5, right? So for example, 15151, the sum of digits of the instructor is going to be 6 plus 6, 12, 13. 13 mod 8 is going to be 5. Again 3, 3, 4, 5, 6. So it's going to be 6, 10, 15, 21. 21 mod 8 is going to be 5, and so on. So whenever multiple records, they refer to the same location or a bucket address, will be performing bucket chaining, right? So this is how we do perform generation of a hash key based on here the instructor ID in the instructor file, right? So here you use a simple hash function, which is going to be the sum of the digits in the instructor ID mod 8, right? So hope you can follow it, right?
Yes, sir.
Yes,
Right.
sir.
Yes, sir.
Right. So this is how we are going to create a hash index for records that are present in a table. Right. I have some more description about this. I think let me check it out. Right. So for example, consider a hash file organization for instructor file using the search key department name. Right. So you assume that there are 10 departments, so maybe 10 buckets. So the binary representation of the ith character is assumed to be integer I. So the hash function returns the sum of binary representation of the characters modulo 10. Right. So what is here we have a hash function which returns the sum of the binary representation of the characters modulo 10. So for making simple things simple, like let us assume that the music department belongs to the bucket 1. So hash of music is going to be 1, hash of history is equal to 2, hash function of physics is going to be 3, and hash of electrical engineering is going to be again 3, right? So you have some information like whenever a person belongs to music department, he belongs to the bucket 1. Similarly, a person belongs to history, so all the records related to history department will be stored in the bucket address 2, and all the records related to physics and electrical engineering department will be stored in the bucket 3, right? So as we have initialized, so history belongs to the bucket 2, right? So history you have music belongs to the bucket 1. So all the instructors who are associated with the department of music, they are placed in the bucket 1, and bucket 2 is it represents the instructors associated with the history department, right? So all the instructors associated with the history department, they are present in the bucket 2. And similarly, bucket 3, we have initialized that they belong to the department of physics and electrical engineering, right? So all the employees or instructors who are associated with the physics and electrical engineering department, they are associated with this bucket 3, right? So similarly, we have bucket 4 for finance department, bucket 5 for biology department, bucket 6 for computer science department, and so on, right? So here it's going to be the hash organization of the instructor file with a department name as the key, right? So in this case, we are going to have department name as the key. So if we belongs to music department, all the records related to music is placed in bucket 1. All the records related to history department, instructor records related to history department is placed in bucket 2, and so on. So this is one way of representing or generating a hash file for instructor relation, where we are going to work on search key with department name, right? So the previous case we saw, we were using search key was using the instructor ID. It's going to be the sum of digits in the instructor ID mod 8, right? So sum of digits in the instructor ID mod 8, you get the bucket address of the particular instructor, right? So these things you need to know while you are working in hashing, how to organize the records in a file by using hashing, right? So we have seen an example for hash function, right? So you are using either a hash function h of k is equal to k mod m, or h of k is equal to k mod plus 1, where k is going to be the hash key and m is going to be the prime number, which is going to be greater than the total number of keys. And using that, we were generating the hash address or bucket address for the two IDs 1024, 2448, 3346, and so on, right? So